Good day all, this is Professor Friday coming at you one more time from Macomb Community College. So today we're doing a little bit of trigonometry. Today we're going to be graphing an angle that's in standard position and trying to figure out the 6 trigonometric ratios of that angle. We're given that the cosine of theta is equal to 15/17 and that the sine is less than 0. So anytime we get started on one of these types of problems, I want to do two things. First one is copy down this bad boy right here, because this is one of the greatest mnemonics I've ever heard in my life. SOHCAHTOA. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. More importantly, we should ask ourselves, given this information about theta, what quadrant could theta possibly be in? Now, we're told in the problem that the sine is definitely going to be a negative value. If the sine is negative, we know that all students take calculus, and that this is a mnemonic for what is positive in what quadrant. So with that in mind, the sine is positive in both quadrants 1 and 2. So it definitely can't be one of those. In addition, the cosine is a positive value. Cosine is positive in 1 and 4. Since we've already eliminated 1 as a possibility, we know that theta is going to be a quadrant 4 angle. So what I'm going to do is draw a generic quadrant 4 angle, like so. Doesn't really matter exactly how I draw it. Here's theta. In addition to drawing in theta, I'm also going to draw the associated reference triangle, like so. Now we've been told that the cosine of this angle is equal to, if we reference the top of the page, this is equal to 15/17. What we're supposed to figure out is what is A and B and R for this angle. Now given that it is the cosine, we see the cosine as the opposite over the hypotenuse. So in our reference triangle, that means that the x-coordinate is going to be 15, and that the hypotenuse is going to be 17. In terms of the book's notation, what we just found is A and R. So the question is, if we know A and R, how do we find B? Now, my class is usually really good at responding to this, and they say Pythagorean theorem, and I say that's exactly right. So, let's copy down our Pythagorean theorem as it applies here. We got a squared plus b squared is equal to r squared. So let's plug in what we know and solve for what we don't know. We got 15 squared plus b squared is equal to 17 squared. You can use a calculator for assistance if you care to. We get 225 plus b squared is 289. We'll subtract 225 from both sides. So upon subtracting 225 from both sides, we're going to get b squared is equal to 64. Now that tells us that b is equal to the square root of 64, but more importantly, we need to keep in mind that this is a quadrant 4 angle. Normally when I say that something squared is equal to something positive, there are two possibilities. It can either be positive, the square root, or negative, the square root. Given that we're in quadrant 4 and we're finding a y-coordinate, this is going to be the negative square root of 64. Y-coordinate is negative in quadrant 4. Therefore, your value of b is going to be equal to negative 8. Plugging that back in up here. Once you know a, b, and r for any angle, you officially know everything there is to know about that angle. So, that said, let's copy down our 6 trigonometric ratios. Sine of theta. We know from SOHCAHTOA up top that that'd be sine is opposite over hypotenuse, or in the parlance of what we're doing here, that's b over r. That would be negative 8/17. Cosine we were given in the problem, but if we weren't, that would be a over r, which is equal to 15/17. And the tangent is equal to the opposite over the adjacent, or what we're doing here, that'd be b over a. That's negative 8/15. Now, as soon as I take the reciprocals of all three of these, I've got my other three. Reciprocal of tangent is going to be cotangent This is using our reciprocal identities, so we just flip top and bottom on that bad boy. Negative 8 over 15 becomes negative 15 over 8, and now we got a cotangent. Reciprocal of the cosine is the secant. Reciprocal of the cosine. So we didn't actually have to do any work in this problem to get this, because we were already given the value of the cosine. That's going to be 17 over 15. And then finally the reciprocal of the sine is the cosecant. Reciprocal of that is going to be negative 17 over 8. So final answer for this one, with tons of justification. These use 6 trigonometric ratios. So more important than just listing what the ratios are is the work associated in getting there. So with the given information in the problem, we determine what quadrant, then we draw the angle, and given that we have to have one of the trigonometric ratios, that's going to give us 2 of the values of either A and B, or A and R, or B and R. In this case, we had A and R. Once we get A and R, we calculate the corresponding value for B, then we get all 6 of these bad boys. Alright, I hope that this was helpful. I hope that you're studying hard, and I'll see you for another tutorial soon.